Hello, this is Mrs. Duong. It's May 21st, 2019, and we're going to complete the assignment Systems with Equations in Different Forms. We've moved on to solving linear systems, which just is a fancy way of saying two lines cross at a point of intersection, or the POI. So first you'll have to rewrite these equations into slope-intercept form, where m stands for move. That's our slope. It's either rising or falling, and it's rise over run. If it's positive, it rises. If it's negative, it falls. The b is what we call the begin point. That's the y-intercept. And it's a number in for y on the y-axis. If it's positive, you go up from the origin. If it's negative, you go down from the origin. So the very first example is x plus y equals 8. You want to solve for y, so you have to get rid of the x. Minus x from both sides, drop down the y. Minus x plus 8 is the equation. Now remember, we begin at positive 8. So I count up 8 from the origin. Happens to be the top of this graph. Negative x is that invisible 1. So negative 1 means down 1. And I treat slope as a fraction or a ratio of rise over run. So down 1 and over 1. Then I need to use my ruler, or my line tool in this case, to draw my line. The more points you plot, the more accurate your line will be. In the second equation, again, I'll subtract x from both sides, but this time instead of dropping down y, I have a negative y. So negative y equals negative x minus 2. The negative 2 drops down as a minus 2, but I have to get rid of the negative in front of the y. So I divide it by negative 1 as I do for everything else. So negative divided by negative becomes the positive y equals positive x plus 2. Now I'll begin at positive 2 on the y-axis, which is up 2 from the origin. The slope is 1, so I treat it as 1 over 1. So up 1 and over 1, up 1 and over 1. And what do you know? I could draw a line, and that line will pass through a point on the other line. Remember, I can get a more accurate line by plotting points in both directions. So I not only can go up 1 and over 1, I can also go down 1 and left 1. I use my ruler or line tool to draw the line, and I can identify the point of intersection as positive 3 to the right. So I put 3, 5 because it's positive 5 up. Moving on to the next question. Question number 2. 2x plus y equals 1. To get rid of the 2x and get y by itself, I have to subtract 2x from both sides. So my new equation will be y equals negative 2x plus 1, because the 1 was positive. Positive 1 is up 1 from the origin, and negative 2 is treated as negative 2 over 1, or down 2 and over 1. Again, I can go up 2 and left 1 if I wish to continue the pattern in the other direction. And then I'll use my line tool as you use your ruler to create a line. Oops, one too many. I'm just going to delete the extra line and extend the first line I drew. So if you notice in the second equation, there's a set of parentheses that we haven't seen in a while. And those parentheses imply multiplication. We know this as the distributive property. So we're going to distribute or multiply the negative 1/2. So my y plus 3 drops down, and negative 1/2 times x is negative 1/2 x, and negative 1/2 times 4, as I'm doing the little side math here, is going to be negative 4 over 2, which is the same as negative 2. So half of 4 is 2, but negative 1/2 times 4 is negative 2. So I still have y with a plus 3. To get rid of the plus 3, I have to subtract 3. The other minus 3 goes under the minus 2 because they are like terms. Drop down my y and drop down my negative 1/2 x, and then negative 2 and negative 3 make negative 5 altogether. I begin at negative 5, so from the origin, I must travel 5 spaces down, plot my first point. Negative 1/2 says down 1 and over 2. I can also travel up 1 and to the left 2 in the other direction to make my most accurate line. Notice when I draw the line, the two lines again intersect. So my goal is to identify the solution point. Oops, I don't know why the green line moved. But my goal is to find the point of intersection. That is the solution to this linear system. And the point of intersection is in the fourth quadrant, so we know it's a positive negative. So I count 4 to the right, and I write 4, comma, and it's 7 down, so negative 7. And that's my point of intersection. Now, if I go to the next page, questions 3 and 4 work very similarly. On the back side, I have 2x minus y equals 8. So first I get rid of the 2x by subtracting 2x. Then I drop down the negative y as a negative 1y. The plus 8 goes after the negative 2x. And now I must get rid of that negative in front of the y and divide everything by negative 1. So my new equation is y equals 2x minus 8. Minus 8 tells me I have to start down 8 on the y-axis. And positive 2x tells me up 2 and over 1, because slope is always a ratio and can be written over 1 if it's a whole number. More points, the more accurate our line is drawn. The next equation says x equals y plus 2. Now, in order to graph the line, we need it in slope-intercept form, so I need to solve for y. So I need to get rid of the plus 2. We're not used to seeing the y on the right-hand side, so instead of writing x minus 2 equals y, I can flip-flop the equation and write y equals x minus 2. Minus 2 starts down 2, and a slope of 1 means up 1 and over 1. That's the invisible 1 in front of the x. So I'm going to use the line tool to graph the line. And the solution point is in the first quadrant, so we know it's a positive positive. So I count to the right, 1, 2, 3, 4, 5, 6. So my POI starts with 6. And then I count up, 1, 2, 3, 4. So my POI is 6, comma, 4. All right, last question, question number 4. Again, both of these involve the distributive property. So I drop down my y minus 3 and I distribute the 2. 2 times x is 2x and 2 times 1 is 2. But I have to get rid of the minus 3, so I add 3 to both sides. I could drop down the y And negative 3 and 3 cancel each other out. So then I have y equals 2x, and I combine 2 plus 3 to make 5. The positive 5 tells me I start my line, it begins at positive 5, 5 up from the origin. Positive 2 is to be treated as 2 over 1, so I go up 2 and over 1, and notice I only have enough room for 1 point. So that means I can go in the opposite direction. So instead of up 2 and right 1, I can also use a double negative, which will land me on the same line, down 2 and left 1. If I follow that pattern, I will end up with the same line. And the more points I have, the more accurate of a line I can draw. So I'm going to place all of the points that fit on the graph before I go and draw my line. Notice the line is rising because my slope is positive. Remember, if the number in front of x is positive, then your line should also be rising. If the number in front of x is negative, then your line should be falling. The next equation says y equals negative 3x plus 5. Distribute the negative 3, so it becomes negative 3x minus 15. But negative 15 does not fit on my graph as a y-intercept since the graph only goes to negative 8. So I'm going to use the strategy of making a table and trying to find the pattern. I know if I were to plug in 0 for x, negative 3 times 0 minus 15 would result in negative 15. So 0 and negative 15 will be my first set of values in the table. Of course, that doesn't fit on the graph, so I'm going to plug in negative 1, where negative 3 times negative 1 is positive 3, 3 minus 15 is negative 12. Then I try negative 2. Negative 2 times negative 3 is 6, 6 minus 15 is negative 9. Negative 9 still doesn't fit on my graph, so I'm going to follow the pattern. The left side's going down by 1, and the right side's going up by 3. Well, adding 3. Whenever you add 3 to a negative, it gets less negative, so to speak. Well, negative 3, negative 6 fits on my graph, so I'm going to graph negative 3, negative 6, left 3 and down 6. Negative 4 and negative 3 also fit on my graph. So I go left 4 and down 3. So I'm following the pattern. It goes up 3 and left 1, up 3 and left 1. And I'm going to plot the remainder of the points. Since negative 3 over 1 is a slope that's down 3 or right 1, can be also rewritten as up 3 and left 1, where the negative is applied to the denominator. If I plot all those points, then I have a line that I can draw, and it intersects the other line that I've drawn. And my point of intersection is in the third quadrant. It happens to be left 4 and down 3, which is my point of intersection, negative 4, comma, negative 3.